Fire is one of those things we interact with almost daily, yet rarely stop to question. We light candles, cook meals, and warm ourselves by it. But what is fire, really? It seems simple at first glance. Something burns, produces heat and light, and eventually goes out. But when you take a closer look, fire becomes much more mysterious. Unlike solids, liquids, or gases, fire doesn't quite fit neatly into the traditional states of matter. You can't hold it, you can't pour it, and yet it clearly exists. It dances, flickers, and changes shape constantly. So today we'll uncover what exactly is fire. To truly understand fire, we have to go beyond what we see and dig into the science happening right before our eyes. Because fire isn't just a thing, it's a process. So let's get into it right here on History of Simple Things. At its core, fire is a chemical reaction called combustion. This happens when a fuel reacts with oxygen in the air, releasing energy in the form of heat and light. That's it. No magic, just chemistry moving very fast. Think of something like wood. On its own, wood just sits there. But when it gets hot enough, it begins to break down and release gases. Those gases react with oxygen, and suddenly, you have flames. The fire you see isn't actually the wood itself burning, but the gases released from it igniting. This explains why different materials burn differently. Paper ignites quickly and burns fast. Wood burns slower and produces more embers. Gasoline, that's almost entirely vapor, which is why it ignites explosively. So when you see fire, what you're really seeing is matter transforming rapidly. For fire to exist, 3 key ingredients must always be present. This is known as the fire triangle: fuel, oxygen, and heat. Fuel is anything that can burn: wood, paper, gas, even certain metals. Oxygen is usually supplied by the air around us. And heat is what starts the whole process, raising the fuel to its ignition temperature. Remove any one of these and the fire goes out. This is exactly how fire extinguishers work. Some cool the fire down, removing heat. Others smother it, cutting off oxygen. And some chemically interrupt the reaction itself. It's a simple concept, but incredibly powerful. Understanding this triangle is also why we're able to control fire, something that was once completely unpredictable and terrifying. One of the most fascinating things about fire is its glow. That warm, flickering light isn't just for ambiance, it's a direct result of energy being released. When the combustion reaction occurs, it excites atoms and molecules in the flame. As these particles return to their normal state, they release energy in the form of light. Different materials produce different colors depending on what elements are present. For example, sodium produces a bright yellow flame, while copper can create blue or green hues. That's why fireworks explode in so many colors. It's all about the elements being burned. Even the typical orange flame of a campfire has its own explanation. Tiny particles of carbon heat up and glow, creating that familiar warm color. It's not just fire, it's glowing matter. Have you ever noticed that a flame always seems to point upward? That's not random, it's due to gravity. When something burns, it heats the surrounding air. Hot air is less dense than cold air, so it rises. As it rises, cooler air rushes in to take its place, feeding the fire with fresh oxygen. This creates the upward teardrop shape we associate with flames. But in space, where there's no gravity, fire behaves very differently. Flames become spherical, forming glowing balls instead of flickering upward. Without gravity driving airflow, the combustion process changes completely. It's a reminder that even something as simple as a flame depends heavily on the environment around it. This is where things get interesting. Fire isn't a solid, liquid, or gas, but it does involve gases. Some scientists describe fire as a mixture of hot gases, tiny solid particles, and energy. In certain cases, fire can even produce plasma, which is often called the fourth state of matter. Plasma occurs when gases become so hot that electrons break free from atoms, creating a charged, energetic state. This happens in extremely hot flames, like those found in stars or lightning. But everyday fire, like a candle or a campfire, is usually not plasma. It's better described as a glowing chemical reaction involving gases and heat. So while fire isn't technically a thing you can classify easily, it's very much real and very complex. Fire wasn't always something humans controlled. In fact, for most of Earth's history, fire occurred naturally, through lightning strikes, volcanic activity, or even spontaneous combustion. Early humans likely first encountered fire as something wild and dangerous, but at some point they learned not just to use it, but to create it. This changed everything. Fire allowed humans to cook food, making it safer and easier to digest. It provided warmth, protection, and eventually led to advancements in tools, technology, and even society itself. In many ways, fire is one of the key reasons humans became what we are today. It's not just a chemical reaction, it's a turning point in history. Fire is one of the oldest companions of humanity, yet it still holds a sense of mystery. It's something we can control but never fully tame. Something we understand scientifically but still find mesmerizing. The next time you see a flame, whether it's a candle, a stove, or a campfire, take a moment to look closer. What seems simple is actually a complex dance of chemistry, physics, and energy. Fire isn't just burning, it's transforming. And that transformation is happening every second, right in front of you. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us in this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.